Okay, so we're starting with question 1 of 2013 because I was requested to the 2013 specifically. So the first question asks about find the gradient of a curve where it's given x squared and y all in one equation. So the expectation is that you're supposed to do implicit differentiation. In unit 1, you learned about differentiation regularly. Now we have to do it implicitly. So we have rewriting it ln x squared y minus sine of y equal 3x minus 2y. For implicit differentiation, it just means that we're going to differentiate each with respect to x still. So the first thing is that we're going to use the law of logs to write this as 2 ln x plus ln y minus sine of y equal 3x minus 2y. Because this is a product, you can take it as addition, and the 2 as exponent bounces to the in front of the ln. Now we can find the differentiation. Differentiating, we have 2, the differentiation of ln x is 1 over x plus 1 over y dy dx. Whenever you differentiate something with y, you have to put dy dx to ensure that it's implicit. Then you have minus cosine y dy dx equal 3 minus 2 dy dx. 1 second. So then the next step is that we want dy dx, and dy dx is almost like a variable. So we're going to bring all of the like terms to one side. So we have 1 over y dy dx minus cosine of y dy dx. Bring this section over, that's plus 2 dy dx equal 3. Bring this section over is minus 2 over x. Factor dy dx, we have dy dx is multiplied by 1 over y minus cosine of y plus 2 is 3 minus 2 all upon x. Dy dx is going to be equal to 3 minus 2 over x all divided by 1 over y minus cosine of y plus 2. Now the actual question, the calculate gradient, it says at the point x equal 1, so this first point is x, and y equals 0. The next step is to just plug those in. So you have 3 minus 2 over 1 all upon 1 over 0 minus cosine of 0 plus 2. This is going to be that this section here is going to basically become infinity. So this entire bottom section is going to become infinity, and this is going to become 1, which is roughly 0. Now it's important to notice that usually is that whenever I have something over 0, it should be like, oh, it's undefined. But the thing is, CAPE is kind of dumb. And the point that they give you 1 comma 0 doesn't even lie on this curve. So this is just the fact that CAPE doesn't always fact check their questions, or at least not recently up to 2023, which is the last paper I saw where they actually took care in their questions. So that's the first part, 0. The next part of the question, part B, says, copying. Next part of the question says that here is a function which takes three things, x, y, and z. Okay, so it's a 3D function. And given that the partial derivative z with respect to y is this, determine this in terms of y. Okay, so you just need to find this section, and put it in this form. So the first step, find the partial derivative with respect to y. So partial derivative with respect to y is going to be, so what it is that partial derivative is when you have 3z squared and y, you treat the entire thing that is not y as a constant. So in this case, to differentiate this as if it was just a constant, so imagine if it was ay, to differentiate this, it would just become a. So it's the same scenario you're going to do here, where you're going to have 3, you're going to have 3z squared. This part has no y in it, so it's 0. This part is minus 3, bring down the 2, keep the y. This part is just a constant, so it's 0. The final answer I get is 3z squared minus 6y. Now you do the same thing for respect to z. So df dz is equal to 3y is a constant. Carry down the 2, leave the z. This front part here is a constant when you're thinking about only z, so that becomes minus e to the 4x. Differentiate this cosine, you get minus sine 4z. Differentiate inside, I get 4. This section here has no z in it, so it's a constant, so that's minus 0. And this right here is also a constant, so that's minus 0. Final answer for this one is 6yz plus 4e4x sine 4x. Okay, that looks correctish. That looks correctish enough. So now they said they want this part, which is z with respect to y. So this z with respect to y is going to be negative of what we calculated first. So that's 3z minus 6y upon 6yz plus 4e to the 4x sine 4x. Up to this point, anybody has any issues? Any issues that I need to clarify here? Nope, we're good. Okay. The next part of the question says, this says the Orville's theorem. Okay. The Orville's theorem. The Orville's theorem. That's it, pronunciation? Oh my God, pronunciation. Okay, so once it's to prove this, the first step every time is just going to say by DEMOIVRE cosine. Now, if you realize that this is a 5, which means that we're going to have cosine theta plus I sine theta to the power of 5. is identical to cosine of 5 theta plus I sine 5 theta. Now, before we even continue and say about to expand the left-hand side, we're going to do selective expansion. So we're going to say, observe the left-hand side, which is cosine of theta plus I sine theta to the power of 5. Now, if you remember expansion, the answer for this will become the sum of r equal 0 to 5 of 5 choose r cosine theta to the power of 5 I sine theta to the power of, let's make this 5 minus r. It doesn't matter much, but 5 minus r, and this is r. Now, is anybody unfamiliar with this equation? This equation comes from, I believe it's module 3. Anybody is like not familiar with this equation any at all? No? Okay. So since you have that, we're going to do selective expansion. We're going to say selective expansion of real components. So now the question becomes, which components in this case are real? The first real one we know will be the constant. So the constant in this case occurs when r equals 0. And that would give us 5 choose 0 cosine theta raised to the power of 5 minus 0 I sine theta to the power of r. R in this case is 0. So this part is cancelled because it becomes 1. This part is cosine to the 5th, and this part is 1. So this becomes 5. This becomes cosine to the 5th power. Any issues with that so far? No. Okay. The next part that would be real is if we had I squared. In this case, I squared occurs when r is equal to 2. So we have 5 choose 2 cosine theta to the power of 5 minus 2 I sine theta to the power of 2. This would give us 10. This part is cosine to the third theta. This is I squared sine squared theta. I squared is negative, so this is negative 10 cosine cube theta sine squared theta. We're going to change the sine squared because we realize that we don't want any signs. If we look up to the right-hand side, there's no signs involved. So we only want everybody to be in terms of cosine. So we now write this as negative 10 cosine to the third power 1 minus cosine squared theta. That's identity. This becomes negative 10 cosine cube theta plus 10 cosine to the 5th power theta. The next real part of the left-hand side will be I to the 4th power. I to the 4th power occurs at r is equal to 4, which is 5 choose 4 cosine theta to the power of 5 minus 4 I sine theta to the 4th power. That part is 5 choose 4 is 5. This is cosine of theta. This is I to the 4th power sine to the 4th power. I to the 4th power is positive 1. So this becomes 5 cosine theta sine 4 theta. This is now 5 cosine theta sine squared theta r raised to the power of 2. Now, if you know the identity for sine to the fourth, then you wouldn't need to write sine squared to the power of 2. This is if you didn't know the identity, and I assume most people don't know the identity. So that's 5 cosine of theta, 1 minus cosine squared theta squared. This is now the expansion, which is 5 cosine of theta, cosine to the fourth theta, minus 2 cosine squared theta, plus 1. This is 5 cosine to the fifth power, minus 10 cosine to the third power, plus 5 cosine theta. So now we have our real parts. The next step is that we need to add our real parts together and see when it becomes right-hand side. So adding all real components, we have the real components is everything that we just calculated. So we have the first real part, which was cosine to the fifth. The second real part, which was negative 10 cosine cubed. And the third real part, which is 5 to the cosine fifth. Now we need to add them together. Adding them together, we have cosine, okay. Adding them together, we have cosine to the fifth theta, plus negative, okay, plus negative 10 cosine cubed plus 10 cosine fifth plus 5 cosine fifth minus 10 cosine cubed plus 5 cosine theta. We have to look for like terms, which is cosine to the fifth here, cosine to the fifth here, cosine to the fifth here, cosine to the fifth here. So that gives us a total of 5 plus 10 plus 1 is 16 cosine fifth theta. The next one is cosine cubed. So cosine cubed is here. Cosine cubed is here. That becomes minus 10, that's minus 20 cosine cubed theta. And the last part is the constant, which is 5 cosine theta. If you look at this, so that's 16, negative 20, and 5. 16, negative 20, and 5. That means the left-hand side, which we're working on, is equal to the right-hand side. Equal right-hand side. Any confusion that you want me to go over on this question? Good. Okay. This one is about complex numbers and proving proofs to complex numbers. Okay. Paste. This is complex number. Okay, so There's a complex number, -1 plus I r raised to the power of 7 we need to write it in that form, polar form, r e I theta. Okay. Okay. So step one is let's say let t be -1 plus I. So we don't need it to the power of 7. We're going to say that let t just be what's inside currently. In that case, we need to just get this being, so this is -1, +1, so t is over here. This is the angle that it has. So we need to find the angle, right? So that's theta equal, it's in this quadrant, which means it's pi minus tan inverse of -1. Plug in a calculator, you get 3 pi over 4. So the angle here is 3 pi over 4. We need the magnitude of t now. So the magnitude of t is going to be equal to the square root of -1 squared plus +1 squared. This gives us the square root of 2. So then we can have it as t is then equal to the square root of 2 e to the power of 3 pi over 4 I. Now we have to remember that z is actually t to the power of 7. Realize that we replace the inside here with t. So we need to raise it to the power of 7. So that's square root of 2 e to the power of 3 pi over 7 I raised to the power of 7. Individually, that's square root of 2 raised to the power of 7 multiplied by e 3 pi over 4 I raised to the power of 7. The first step is that you need to plug the first part in your calculator, which is the square root of 2 to the power of 7. You get 8 square root 2. And then the e part, when you're raising something to the power again, you just need to multiply it. So that becomes e to the 21 pi over 4I. However, we can't do that because the angle, even though this answer is perfectly correct, the angle that's up here should not be this large. Because reminder is that the expectation is that it should be between -pi and +pi. So this 21 pi over 4, we need to transform that into the primary angle. So the way that you could do that, what are those ways work? That way. Yeah, okay, let's do that way. We're going to try to transform 21 pi into the primary angle. So first step is to find out how many times does 21 pi over 4 go around the circle. So 21 pi over 4 divided by 2 pi. Negative 3 pi over 4. Okay. So, so So this goes around the sphere, the Cartesian plane 3 times, right? So that's 1, 2, 3. So it goes here, and then that's 21 pi over 4 minus 3 times 2 pi, which gives us, forget calculator, negative 3 pi over 4. So this 21 pi over 4 is the same thing as negative 3 pi over 4. So the final answer is 8 square root 2 e to the power of negative 3 pi over 4i. This is z. Any issues? No problems with this. Okay. The next part says, hence prove that this is the same thing as negative 1 plus I. Okay. Scroll down to here, paste. This section. Okay, so to prove this, we're going to start off with the left-hand side. I'm going to have negative 1 plus I to the power of 7, which we already found to be 8 square root 2 e to the power of negative 3 pi over 4i. And now we need to change this from the polar form to cosine and sine. So we're going to have 8 square root 2 cosine of negative 3 pi over 4 plus I sine negative 3 pi over 4. This gives us 8 square root 2 negative square root 2 over 2 plus I negative 2 negative square root 2 over 2. Then minus, I give a plus. The 8 stays here. Square root 2 times this is going to give us no, 2. It's going to give us, okay. It's going to give us 2 over 2 plus I negative 2 over 2. This is then 8 negative 1 minus I. Throw the negative outside, so that's negative I, 1 plus I. Final answer, right-hand side. Any issues with this part? No, we're good. Okay. Next question goes into module 2. Nope, still module 1. This says to do the integral of sine x cosine 2x. Okay. The integral of sine x cosine 2x. So the first thing before I even begin, I'm going to assume that we don't know an identity, because sometimes it's okay to assume we don't. And I'm going to realize that I don't I'm going to realize that this looks very similar to product to sine. Product, the sum of two angles. Sum of angles to product. So I'm going to first start off with two identities that are on the paper. So sine of A plus B is equal to sine A cosine B plus sine B cosine A. And then if we're supposed to subtract instead now, sine A cosine B minus sine B cosine A. If we're supposed to add those two identities together, we get sine A plus B sine A minus B is the same thing as 2 sine A cosine B, and this cancels out. I know this looks very similar to what is inside the integral. So for it to be inside the integral, we're going to say that A equal X, B equal 2X. That means that sine of X cosine of 2X is going to be equal to a half sine A plus B, 3X, sine, there's an addition here, plus A minus B is minus X. And we're going to plug that into the integral. So we're going to have the integral of sine X cosine 2X dx is the same thing as integral of a half sine 3X plus sine negative X dx. The reason I do that is because you cannot integrate a product like this. Instead, it would be so much better if it was a sum, because you can integrate them individually. So bring the half outside, we have a half integral sine 3X plus sine negative X. One of the things that you should know is that if there's a negative in front of the X here, the negative can go outside for sine. So that's the integral of sine 3X minus sine of X and the half outside. You're going to now integrate them individually. So that's a half integral of sine 3X is going to be cosine 3X all upon 3 minus integral of sine now is going to be cosine. I feel like it's negative. I have a strong suspicion that I am actually backwards.
Aren't you supposed to use integration by parts?
The issue is that I can't use integration by parts here. So integration by parts is useful whenever you have something like the integral of x sine x, right? Because you have a algebra and a trig. So it's whenever you have if you guys have learned ILATE or LIATE, doesn't matter the order, I believe. Either way, it's that whenever you have two different things. But when you have trig here, the expectation is that you should know this identity. You should actually just know it out of your head. But this is how you derive this identity. These two, the first one and the second one, are on the formula sheet that you're given in the math during the exam. So down here, yes, this is what I was talking about. I said this is backward. This should be minus cosine of 3x over 3. This is now plus cosine of x. This becomes cosine 3x over 6 plus cosine x over 2 plus c. Remember to add the plus c because if you don't, you lose a mark. Even if you know the answer, add a plus c, I'm told I get a mark regardless. So up to this point, any confusions? No? Reminder that we could not use integration by parts because integration by parts is whenever you have two separate things. Like you have a algebraic expression and a trig or a log with something else. The expectation is that it shouldn't be the same trigs. So final answer is that, and then it says, the next question says, hence calculate a value. Calculate this. So the calculation of that is going to have the integral of to pi over 2 of sine x cosine 2x dx is going to be negative cosine 3x over 6 plus cosine x over 2 going pi over 2, 0. So first things first is that, okay, so we're going to have negative cosine 3 pi over 2 all upon 6 plus cosine pi over 2 all upon 2. That's the first section. Minus negative cosine 3 of 0 over 6 plus cosine 0 over 2. This is 0. This is 0. This is 1. This is 1. So we get 0 minus negative 1 over 6 plus a half, which is then the final answer being negative 1 over 3. Any issues with this part? Up to here, we're good. Okay. The next question says, here is a... Next question says, this is a here's a fraction. We want to decompose it. So, to decompose a fraction to get like partial fractions, no, they're not called partial fractions. I don't think they're allowed to call partial fractions. Either way. So the step that I need to take is that you're going to say, okay, left-hand side is going to be 2x squared plus 4 all upon x squared plus 4 all squared. And you're going to say that must be equal to ax plus b over x squared plus 4 plus cx plus d all upon x squared plus 4. squared. So it's you just turning them, because originally this is a quadratic. So you're going to say, okay, there must be two linear fractals that can be over these new denominators. Next step is multiplying the entire thing by x squared plus 4 all squared. You get 2x plus 4 being identical to ax plus b, x squared plus 4 plus cx plus d. Let's expand this out. On the right-hand side, we get ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Now we need to say, now that we have two things, if I give you two things on left-hand side and right-hand side, I can tell you that, okay, we need to equate the coefficients, equating coefficients. Yes. We have the constant. For the constant, on the right-hand, on the left-hand side, that's equal to 4. On the right-hand side, that's d plus 4b. So this is a constant, and this is another constant. Then you have the x's, it's supposed to be squared. For the x's, nothing, 0 is equal to 4a plus c, because x's is going to be this 4a and this c. For the x squared component, we say that it's 2 on the left-hand side is equal to the b that's here. And for the x cubed component, we have 0 is equal to the only x cubed is a. So there we go. So now we have some things, right? We have a being 0. We have b being 2. We need to find what these things are. So for this one, we're saying that 0 is equal to 4 times 0 plus c, which implies that c is also 0. For the d now, we have 4 is equal to d plus 4. B in this case is 2. So that means d is equal to -4. So we have each of the answers now. We have a being 0, b being 2, c being 0, and d being -4. So we can rewrite the expression 2 squared plus 4 over x squared plus 4 all squared. Remember that we said that it was equal to ax plus b all upon x squared plus 4 plus cx plus d all upon x squared plus 4 all squared. Now we can replace the a and the b that we just found to be a is 0, b is 2, so that's x squared plus 4. C is 0, D is -4, so put negative out here and the 4 on top. And that's x squared plus 4 all squared, which this is the right-hand side I said to prove. The next question is like going to ask us to do some kind of integral. Yes, it does. Hence, find this integral using the substitution x equal to tan theta. Paste. Okay. Okay. Step 1 is that it says hence, so whatever you did in the previous question, just rewrite it in the second question. So that means we have the integral of 2x plus 4 all upon x squared plus 4 dx is going to be equal to the integral of 2 over x squared plus 4 dx plus the integral of 4 over x squared plus 4 all squared dx. Cool. So now we only need to work on the right-hand side because these are things that we have learned to integrate before. For the first one, this looks like some kind of tan inverse type deal. Like there's a tan inverse here somewhere. So the step I have to take is that you're going to have you want to rewrite this part as 2 outside the integral of 1 over x squared plus 2 squared dx. Now it's in the form that we know, right? Which means that we recall that the integral of 1 over x squared plus a squared dx is going to be equal to 1 over a tan inverse of x over a. So we're going to do that same thing here. So that's 2 multiplied by 1 over 2 tan inverse of x over 2. Up to this point, everybody understand how I integrated the first section? Any issues with that part? No? We're good? Okay. The next section now is where they asked you about doing that substitution x equal 2 tan theta. So the first step is they said to do a substitution, we're going to do that. We're going to say let x equal 2 tan theta. Whenever they say do a substitution, you're just going to believe whatever they say. And you're going to have dx then is going to be 2, the derivative of tan is secant squared theta d theta. Okay, then we can continue the journey. So down here, we're going to replace everything so far. -4 goes outside, integrating 1 upon x squared is now 4 tan squared theta plus 4 all squared. The dx gets replaced with what we have here. So that's 2 secant squared theta d theta. Now here it almost looks like we're stuck. However, we're going to have to remember one more identity. We're going to have -4, the integral of 1 over, factor the 4 out of this. Factor the 4 out of this, we'll have tan squared theta plus 1 all squared 2 secant squared theta d theta. Now the identity I have to know is that recall tan squared theta plus 1 is the same thing as secant squared theta. Okay? So that's what identity that is also necessary here. The next step then is -4, the integral of 1 over 4 secant squared theta all squared 2 secant squared theta d theta. We have -4, the integral of 1 upon 16 secant to the 4th power theta 2 secant squared theta d theta. So then that's -4. This square cancels to make this a square. This 2, 1, 8. Bring the 8 outside. That's integral of 1 over secant squared theta d theta. This is a half. And this right here is secant is cosecant. So this secant squared is same thing as cosine squared, right? But this looks off. Hold on. Why does that look off? Yes, okay, yeah, that's right. That's 1% right. Okay. 1 over secant squared is going to be the same thing as cosine squared of theta d theta. Negative a half is outside. No, this is similar to earlier, where we can't integrate cosine squared, at least not easily. So we have to remember another identity, which is that recall cosine squared theta is identical to 1 plus cosine 2 theta all upon t, cosine theta 2. That's recalling a new identity. So this now can be written as a half integral 1 plus cosine 2 theta all upon 2 d theta. Yep, that's right. How many marks? 7 marks. Makes sense. This 2 is going outside again, so that's 1 over 4 integral 1 plus cosine 2 theta d theta. This is admit. The next pretty much final step is 1 over 4. The integral of 1 is going to be theta. The integral of 2 of cosine 2 theta is sine 2 theta over 2. Now, remember that we have this theta and this theta here, but however, we never start off with any theta, right? We start off with tan. So we have to how do I say it? We can't have theta in our answer, right? Because we can only have x's since we started with x's in the first place. I want to clarify then if you see sine and cosine in here, the expectation is that you should immediately draw a triangle, right? So we have this triangle, the right angle triangle with an angle theta. This is saying that tan of theta is equal to x over 2. We also know that tan of theta is opposite over hypotenuse, no, adjacent. So that means the opposite of this angle is x and adjacent is 2, which means that the hypotenuse is x squared plus 2 squared. Cool. Yes, is that true? Did I butcher that? No, that's right. Okay. Down here, we're going to have theta over 4 minus sine 2 theta over 2. Nope, that becomes 8. And then this part here now is going to become minus theta over 4 minus 2 sine theta cosine theta all upon 8. Now we need to replace the thetas, right? So to do that, we know that theta here is the same thing as tan inverse up here. Remember earlier we said that tan theta is x over 2, so theta is equal to tan inverse of x over 2. And we have sine and cosine we need to find, right? So cosine, sine and cosine. Sine is opposite. Sine is opposite over hypotenuse, so that's sine is going to be sine is opposite over hypotenuse, which is opposite x over hypotenuse. Square root of x squared plus 4. This one is 2 over square root x plus 4. And that's all upon 8. This gives us 4. Do I need to go any further? You know to simplify this part already. So the reason why this question was so long, even though it didn't have to be that long, is because I want to show each step. So on the left-hand side, going back over to it, the left-hand side right here, we need to realize that this is some form of arctan, or tan inverse. So we need to write it in the form x squared plus a squared to get the tan inverse form. On the other hand, this one is where they told us to use a substitution. That substitution is x equal to 2 tan theta. The next step is to do the derivative. Dx is equal to 2 secant squared theta d theta. Realizing a new identity of tan squared theta plus 1, we're able to cancel out and reach the point where we have cosine squared. We need to integrate cosine squared by using a new identity, 1 plus cosine 2 theta over 2. Again, if you don't know this identity, they're all derivable. However, if you need to derive them in the exam, you can probably believe that you won't have the time to. This identity is in the sheet. This identity up here is, I don't believe it's, I don't think it's in the sheet, not in the sheet. Okay. Does module 2 come up next? Module 2 does come up next. Module 2 is about proving a lot of things. Okay. Proof. Prove something for 6 marks. For 6 marks, prove. Listen, we have a sequence starting at 1. The next sequence is defined as 4 plus 2 cube root of the previous number. Use mathematical induction to prove.
What?
Asking me a question? Asking me a question?
Apa man? Yeah, anak kelas. Bagaimana?
So it says prove by mathematical induction that the number will never be greater than 8 and it will always be greater than 1 for all elements of positive integers. Okay, if you don't know how to do the question, you must always follow the same rules for mathematical induction. So the first thing is you're going to do the base case. This is 1 mark. So base case, it says all positive integers. So the first positive integer is n equal 1. The first positive integer is n equal 1. So we have a of 1 is equal to 1. This is true because 1 is less than or equal to 1 is less than or equal to 8. 1 is greater than or equal to 1 and it's less than or equal to 8. So this part is true. That's 1 mark. The next step of our mathematical induction is for n equal k. Assume that 1 is less than k to the 8. Okay, this is where you make an assumption. So whatever they told us, we're just going to assume that, yep, whatever you said, I believe you, it's definitely true. Don't worry, just believe it for now. The next step is the induction step. We're just going to be like, okay, I believe what you said. Let's test if the next one is going to hold up, if that's the case. In this case, we're going to start off with, okay, start off with 1 is in the range of k 8, right? The next, what we're going to do is we're going to do the cube roots. So that's 1 is less than the cube root of a k. The cube root of 8 is 2. We're then going to multiply it by 2 to get 2 is less than or equal to 2 ak less than or equal to 4. Add 4 to both sides, that becomes 6. That becomes 6 is less than or equal to 4 plus 2 cube roots. AK less than or equal to, add 4 to 8 to get 8. Add 4 to 4 to get 8. Now, this 6 is less than or equal to, what is this middle section? This middle section is literally just AK plus 1. Because that was the definition that they gave us up here. So we just proved that AK plus 1 is between 6 and 8, which if it's between 6 and 8, that's the same thing as saying it's between 1. No, different color, different color, different color. Less than equal to 1, which means that this is therefore true for k plus 1. The final step is to always have your conclusion. So for the conclusion, you clarify that by PMI, A of n equal 4 plus 2 cube roots. Yep, raised hand.
Just a second. Can you scroll back up a bit? I'm trying to remember why you added 4.
Oh, so I started off with what
Yeah,
I
yeah,
assumed.
all right.
Sorry, what I assumed. I took the cube root. So I'm transforming the original equation, what I assumed. I'm transforming it to look like what they gave me in the very beginning. So I cube root, then I times by 2, then I add 4, so that the inside looks exactly like AK plus 1. Make
Okay.
sense? Okay.
Mhm.
And then
More
that
sense.
range, repeat.
It makes more sense than it did a while ago to
It
trying
made,
to make consistent.
but it makes sense now?
Yeah, it makes more sense
Okay.
now.
Okay, so this middle section is AK plus 1. And so AK plus 1 is between 6 and 8. 6 and 8 is between, we know that 6 and 8 is already between 1 and 8. So that means it's also true. So then we need to find the right conclusion. What's important is, even if you don't get the answer here, so imagine this part didn't work out for you, it's very important that you said by PMI, regardless, have the conclusion. By PMI, A of n, 4 plus 2, cube root n plus 1. That's what I was missing. A of n will have 1 is less than A of n to 8, where A of 1 is equal to 1 for all n in the set of positive integers. So this is me writing a conclusion. I need to tell them by PMI, so the way that I did it, the statement that they gave us, so they gave us all 3 of these things. and tell them the range that you're allowed to go in for. N is in the set of positive integers. Cool. The next question is another proof. Oh, there's a lot of proofs, huh? Show da 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 da. Okay. Okay, this is a 3-mark question. This one says f of k minus k plus 1. So, left-hand side. F of k minus f of k plus 1. What we're going to do is we're going to have 1 over k minus k squared, sorry, minus 1 over k plus 1 r squared. That's what f is. Now, if you look on the right-hand side, the first thing we look on the right-hand side is that this is one fraction. We currently have 2 fractions. So the next step has to be turned into 1 fraction. So the denominator at the bottom is k squared, k plus 1 squared. Then the top part becomes k plus 1 squared minus k squared. Now, before expanding it, because you can expand it definitely, we could also realize that this is a difference of 2 squares. And we can remember, we can say recall. So this is us just remembering that we can always recall stuff. A squared minus b squared is equal to a plus b, a minus b. So in this case, it would then become k plus 1 plus k multiplied by k plus 1 minus k, all upon k squared k plus 1. The final answer then is that this k cancels this k. This is 1, that's 2k plus 1, all upon k squared k plus 1 all squared. This is missing a square. Okay. That is the right-hand side. Any issues with that question? Good at that one, right? Right-hand side. Okay. The next part says, okay, you showed that stuff. It's time for you to show a sum. Okay. Sum. Sum. Scrolling down back to here, we have a sum. Here. Paste. Okay, it says to prove that one now. Um, 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 okay, cool. See, so this is called the telescope method, where it's going to be, this is going to be the left-hand side. So to the left-hand side, we get the sum of k equal 1. We start from k equal 1, going up to n. Going up to n, we want to calculate 1 over k squared minus 1 over k plus 1 all squared. In this case, we're going to have the telescope. We're going to be like, okay, so this is, imagine if we're supposed to add all these things, do this, right, by hand. It'd be 1 over 1 plus 1 over 2 squared plus 1 over 3 squared, going on forever up to 1 over n squared. Okay, so that's the first part. This is this section. And from that, we keep minusing 1 over 1 plus 1 squared minus 1 over 2 plus 1 squared plus 1 over 3 plus 1 squared. Going up, we reach to 1 over n, 1 over n squared, 1 over n plus 1 squared. Cool. In this section, now we need to realize that this is going to become 1 over 2, or different color. This is going to become 1 over 2 squared, right? So then that means this cancels this. This is going to become 3. This is going to cancel this. And it's the same pattern happening, right? Until here and this cancels. And we're finally left with two things. We're left with 1 minus, and what's left in here is this part. So that's 1 over n plus 1 r squared, which is the right-hand side. Any confusions with that? We're good at that part? Any issues? Okay. The final part for that says, hence or otherwise, prove that the sum becomes 1. As n becomes infinity, prove that the sum becomes 1. Okay. So for this case, this proof is just, if we find the sum to infinity, we already know that this is going to be the limit of n approaches infinity of 1 minus 1 over n plus 1 r squared, because that's what we found. That's what we found earlier. And that is then going to be 1 minus 1 over 0. Sorry, over infinity. Because this section, this n is infinity. So infinity plus 1 is infinity. Infinity squared is just, again, infinity. Like, it doesn't matter. And this entire thing is equal to 1, which is the right-hand side. Any issues with that question? No?
Hold on. Where did you insert? So wherever there's a K, you inserted infinity, right?
Oh, I'm sorry. One more time?
Wherever there was a K, you inserted infinity. You substituted with infinity, right?
Yeah, I switched out with infinity because this entire section here, the
Mm.
sum is going to be what we calculated earlier of 1 minus 1 over n plus 1 r squared. But the n
Oh,
in this case is infinity.
oh,
Makes sense? Mm-hmm.
it makes
They
sense. But
use
I was
the
wondering where you took it. Okay, so you have
limit?
the 1 minus 1 over n plus 1. So then
Yes.
where did you get your right hand side value?
It's
Okay.
important. Well, it's somewhat important that you said the limit of n approaches infinity because um um you can't actually put infinity inside here. You have to like set limit. But like I don't think it's matter whether or not I set limit or just put in infinity. But the correct notation is to say that, oh, I'm taking the limit as n approaches infinity. But it doesn't matter too much. Not at least not for K.
Yeah. Okay, thank you. I was just looking for the equation that you use, like the one that you were
Oh, okay.
using to. Okay, but I found it. Thank you.
Yeah, up there. Okay, so the next part, are we in module 3? Nope, we're in module 2. Is still in module? Oh, module 2 is what? These papers are long, you know? Oh, you get 1 minute per quest. You get 1 mark per minute. Oh, that's wild. Okay. This one is Taylor series expansion. When do we take the break? Take the break after this question? That's 5:30. I think that's good. Okay, so So obtain the first four non-zero terms of the Taylor series expansion. Okay. Okay, so the expansion is just going to be f of a plus the first derivative a x minus a plus the second derivative with a x minus a squared over 2 continuing down the line. Okay, so we're fully aware of this of this as the Taylor series, right? We don't that's something we are fully aware of. I'm going to assume yes, nobody should be unaware of. Okay, so in this case the a is pi over 4 is that a that we're taking into consideration. So the first step is f of pi over 4. It needs to be cosine of wait 1 second. Where's my calculator? I lost it. Okay, teacher. Radians. Cosine pi over 4. Okay, so cosine pi over 4 gives us root 2 over 2. The first derivative of pi of cosine is going to be negative sine. And we plug in pi over 4 still. And we get negative sine, we get negative square root 2 over 2. We do the second derivative, which is going to be negative cosine pi over 4. We get negative 2 over 2. And then you get the third derivative, pi over 4, which is going to be negative cosine pi over 4, which is going to be positive 2 root 2. So now the last step is to fill in all the values that I found here into the equation. So that becomes f of x is going to become 2 over 2 plus minus 2 x minus pi over 4 plus, again, it's still minus root 2 all upon 4, because we realize there's a 2 down here already. So the 2 that's here is going to become 4. X minus pi over 4 squared plus 2. This is going to be 6. So the 2 here, x minus pi over 4 cubed. Now this is kind of finished. You just need to say that's root 2 over 2 minus root 2 over 2 cosine x minus pi over 4 minus root 2 over 4 cosine. Nope, not cosine. So that where cosine come from? X minus pi over 4 squared plus square root 2 12 x minus pi over 4 cubed. Any issues with that question? Makes sense, right? Any issues? Nope. Okay. So the next part is asking us now to do an approximation. The approximation. Okay, make that approximation. So the approximation in this is just us. So cosine of pi over 16 is going to be approximately equal to this of pi over 16. In this case, it becomes root 2 over 2 minus root 2 over 2 pi over 16 minus pi over 4 minus root 2 over 4 pi over minus 16 minus pi over 4 squared plus root 2 over 12 pi over 16 minus pi over 4 all squared, all cubed. There we go. This is where you just throw the entire thing in a calculator. Throw the entire thing in a calculator. There's no reason for you to feel like, say, you need to do any math in your brain or that like that. Okay? So that is root 2 over 2 multiplied by 1 minus pi over 16 minus pi over 4. Hold on. Pi over 16 minus pi over 4. Okay, that's root 2 over 2 multiplied by 1 minus answer minus answer squared plus answer cubed. Plug in a calculator, I got 0.7. Nope, that look wrong. That just look wrong. Oh yeah, I butchered that really bad. You get 0.98. No, you need 3 significant figures. Remember that they asked for 3 significant figures. 3.977. That's your answer. This has no units. Okay, cool. The next part of the question 4, says obtain the binomial expansion of this up to and leading to the term x squared. This, okay. This. Cool. Okay, binomial expansion. We write in the power format. Before we do that, let's do the recall. Recall 1 plus x to the power of n is going to be 1 plus nx. What's the formula for this again? Yeah. Plus n minus 1. That's so wrong. I'm going to assume that is correct. X squared over 2, continuing the journey. That does so wrong in my head. Hold on. Double checking that formula. I also believe that this is on the formula sheet. Expansion. Yeah, it is. Okay. Okay, yep, it is. Okay. And 1 minus x to the power of n is going to be 1 minus nx plus n minus 1 over 2 x squared, repeating the process. Okay, so we're going to rewrite these to the power format. So that becomes 1 plus x to the fourth plus 1 minus x to the fourth. Cool. Now we're going to regurgitate, just put these back as they're written. Of 1 x squared, 1 plus x squared is 1 plus 1 over 4 x plus 1 over 4 negative 3 over 4 x squared over 2 plus 1 minus 1 over 4 x plus 1 over 4 negative 3 over 4 x squared 2. Then the answer becomes 1 plus 1 is 2. This cancels this. This is adding together. So that's 4, 16, 2. Negative 3, 16. So that's negative 3 over 16. That's x squared. Cool. The next part of the question is saying, okay, you found your answer. It's time for you to use your answer in an approximation. So whenever you do the binomial expansion, it's going to ask you about doing it in an approximation. The approximation will always tell you what to make x equal to. So now we're going to have 1 plus 1 over 16 to the fourth. No, that's not what the fourth should be. To the 4 plus 4, open bracket, 1 plus 15, 1 plus, that look wrong. You see, these are things that just looks wrong. Okay, hold on. 1, 16, 17, 15. Oh, okay, it's 1 minus. That's why. Okay. And this one is now to the fourth power, to the fourth radical, 1 minus 1 over 16. So then we have 17 over 16 fourth plus 15 over 16 fourth. we're going to plug in our answer. This gives us 2 minus 3 over 16. The x in this case is 1 over 16 squared. Plug in a calculator. So that's 2 minus 3 over 16 times 16 squared. We get 1 point. Well, look off. No, I have to believe them, you know. I'm gonna believe them. Okay, so that becomes 1.999. Yep, okay. Or you could say that that is 2.00 to 3 significant figures. Any issues with this question so far? Good with this? No issues? Okay. Um, okay, so the question, I just realized the question is not complete. You can't do that because I realized that I didn't finish question. So right here, where is it? Okay. So the answer I got is not exactly what they want because they require you to have look at the what we found, right? We found this, but that's not what they have. So we need to say, okay, this part is then the fourth root 17, fourth root 16, plus the fourth root 15, fourth root 16. The fourth root of 16 is 2. Don't know if you're aware of that. It's 2. Can put in a calculator and show. So then we need to multiply this entire thing by 2 to get rid of these. And so we have to multiply the entire section over this side by 2. So then the final answer is 4. That sounds wrong too. Let me put them calculator for the exact value. 17 to the power of 0.25 plus 15 to the power of 0.25. Final answer? Yep, that's right. So it's 4.00 to 2 significant figures. 3 significant figures. Any confusion with this question? We're good at it? Any issues? Okay. The next part, next question talks about intermediate. Nope, it talks about, oh, okay. The first one is another binomial expansion. Here. Okay, so it says that you should expand to get the x to the 5th term. When you do this, you're going to realize that you can't just expand it as you can't do the whole expansion because it's 7 marks and you don't have all time to work. Remember that this is a speed exam. Okay, so how will I explain this to do? So that makes sense. Okay, what we're going to do I'm wondering if you guys know that formula for multi-head as it on the paper. Like it's not on the paper. Okay. You're going to expand it out. So let's start with the x plus 2. But the expansion you're going to do, you have to do it such that it's the expansion that you have to do here is that you can't expand it or like the 4, you have to use like Pascal's triangle, or in this case, the choose sum. So it's the sum of up to 5, starting from r equals 0, of x to the power of 5 minus r multiplied by 2 to the power of r.
Why is it not changing? Go on the audio too.
So the
The
expectation is
audio.
that
Oh, I'm with that.
so the expectation is that you're going to expand it out this way. So that's multiplied by 5, choose r. So it's going to be 5, choose 0 of x to the power of 5 multiplied by 2 to the power of 0 plus 5 choose 1 x to the power of 4 2 times 1 plus 5 choose 2 x to the power of 3 times 2 to the power of 2 plus 5 choose 3 x I need to zoom out so you can see it. Yep, okay. 5 choose 3 2 3 5 choose 4 x 3 2 4 5 choose 5 x 5 x 0. Nope, that don't even look right. It's supposed to be 1. Okay. 0 2 5. Okay, so this is the expansion for the first section. Okay, which if we work it out, this is going to become x to the 5th. This becomes 10 x to the 4. Do this in a head card. I need to get my calculator. Choose 5. Choose 5, 5, 5. Choose C. Okay. So that's now 40 x3 80 80 x squared 80 x1. This looks off. This looks like it's not adding up properly. Where's my... It might be right for real though. 2, 10, 40, 80, This looks wrong. 1 second. Nope, it's right. 80x plus 32. Cool. Admit. Now we're doing the same process. So we did it for one. We're going to do the same process for the second one. So that's x minus 2 after that same process, but this time it's going up to the power of 4. So it is going to be the sum up to 4 of r equals 0, 5 choose r, x to the power of 5 minus r multiplied by negative 2 to the power of r. Cool. So now this is going to be, do I need to write it out for you guys? I don't think so. X to the 4 minus 8x cubed plus 24 x squared minus 32x plus 16. Now, what's important here to notice is that there are sometimes we're looking for the x to the 5th term, right? There are some of them that we just don't need to have for the x to the 5th term to make up and make sense. So let me see if I can try to find a way to explain it. We're multiplying these two things together. We're multiplying this one and this together, but we're only looking for the x to the 5th terms. Okay, so what we're going to do now is look for anything that could multiply together x to the 5th and use those only. Okay, so we have okay, so quickest way to show you guys that makes sense, right? All right, so I can use a different color. That's what I can do. Okay, different color. This x to the 5th, to get an x to the 5th from this, we'd have to multiply by the 16. So that means that we can have 16 x to the 5th. Now, for this one to give us x to the 5th, you would have to multiply by this one to give us minus 32 x to the 5th. So we're looking only at the x to the 5th terms. This one would multiply by this one to give us x to the 5th. So 40 times 24 equal 960. So that's plus 960x to the 5th. For this one to become x to the 5th, we would have to multiply it by this component. So that becomes minus 160x to the 5th. Now, for this one to be x to the 5th, it needs to multiply by this one. So that becomes positive 80x to the 5th, 80. For this one, there is no part I can multiply over here to give us x to the 5th, right? So that means it doesn't count. Okay? Then the last step is to figure out what number this adds up to. So 16 minus 320 plus 960 minus 960 plus 80 gives us 576. That look wrong. No, I need to do the not add the thing properly. Dun. 960 minus 60, 80, 80, 16. One more time. 80. This is not right. This is. This is not. This is one that's not right. Okay. This came from the 8 times 80, but that's not correct. So this times this times this, 40 times 24 give us 960. 8 times it should be 64. So that's 16 minus 320 plus 960 minus 640 plus 80. And that gives us 96 that I'm expecting. Okay. 96 x fifth. Therefore, coefficient of x to the fifth is 96, hence shown. Any questions about this? Or did here? Any issues with it? Okay. The next question is intermediate value theorem. So for this, it says intermediate value theorem. We're going to have let f of x equal x to the 3 minus 25. For intermediate value theorem, all I have to do is just check between these two ranges so that we get we say let f of x be x cubed minus 25. We plug in 2 and we get negative 17, which is less than 0. And f of 3, which is equal to 2, which is greater than 0. Note to say, no need to have the conclusion. So the entire marks is coming from the conclusion that therefore, since f of x is a continuous function on 2, 3 enclosed, and f of 2 is less than 0, and f of 3 is greater than 0. Hence, by intermediate value theorem, there exists, I don't need to say there exists. It's up. This is simple, but there exists. So there exists a C in the set 2, 3, where f of C equals 0. So the most of the marks comes from this conclusion you have to make. You say calculate the points at both ends of the range. Then the next step is to say a conclusion that is very clear. You need to tell them that f of x is continuous. It's very important that you tell them, say, yeah, man, it's a continuous function. Because if it's not continuous, then the intermediate value theorem doesn't fold. Then after telling that it's continuous on the range and that 1 is greater and 1 is less than, then you just need to tell them that, okay, I'm IVT, intermediate value theorem, tells us that, okay, there must be a root. The next question is asking about interval bisection. Below shows the result of the first 4 okay. Okay, complete the table and up. Okay, complete the table. And that's complete the table. Complete this table. Okay, so one second. Does this require me to show the equation? Let us ask me for, it says complete the table. Procedure used is that as starting point and estimate of the unit end. Okay. Okay, so the whole point is that we're going to keep halving between them until we find wherever the range is. So in this case, right? Let's try to draw a diagram because I don't know if the teacher covered, because a lot of times teachers don't cover things in their class. So we're saying on this number line, right, there exists this point 2,875 and the point 3. When you plug in this value, you're up here. Which means that the answer is still in this range. Getting the thing right. So we're going to have one second. This is 2.875 plus 3 by 2. Plus 3.875. Okay, so hold on. I'll be back. Okay, so let's look back at the question that we were last. Our teacher was asking us about interval bisection. So I wanted to go ahead and explain how interval bisection works because this is module 3, this is the end of module 2, which means it's likely that teachers didn't teach it, or the end of module 3, which teachers oftentimes don't teach any at all. So for this, we're going to draw the number line at 3 and 2. Reminder earlier, if we look back earlier, we remember that when we calculated 2, we got a negative number. When we calculated 3, we got a positive number. So that means the graph on the 2 side is in the negative region, and on the 3 side is in the positive region. What they did is they found the point in between, which is 2.5, and they tested it and they got a negative number. So that's 2.5, they got a negative number. If they got a negative number there, that means the root that they're trying to find is nowhere on this side. It's between these two numbers. So then they find a number that is between 2.5 and 3. So between 2.5 and 3, the number between it is 2.75. They found that number and they tested it and they got a negative number, negative. So where is the root between? It's between 2.75 and 3, so it's not in this region. They keep repeating the process. So here, which is 2.875, they tested it, they got a negative number, which means it's not in this region. Now I'm going to take a zoom up. I'm going to start at 2.9375. Nope, we can't start there. Okay, hold on. We're going to start at 2.875. This goes up to 3. So in the 3 region, it's positive. In the 2.8 region, we found it to be negative. The number between them that they found was 2.9375. When they plug that number in, they got a positive value, which means that it's in the positive region. That means between the negative and the positive here, that means it's not in this region any at all. It's not in this region any at all. No, you know, it's between 2.875 and 2.973. The next step is to find which number. So now that we're finished with their answers, it's time for us to put our answers in there. Our answers, we'll first have to know what's the number between 2.875 and 2.9375. So, so the number in question is, so the number that it's now between, it's 2.875 and 2.9375. The number between those two is 2.90625. When you plug it in a calculator, you get a negative number being negative 0.45. So that means the number in between here gave us a negative number, which means it's not on this side. It's between these two numbers. So now the new number is 2.90625 and 2.9375. Number between them is 2.921875. Plug in a calculator, I get negative 0.05. And that's enough. That is pretty close to our answer. So we're going to tell them that the root is therefore 2.92. So this answer we found, 2.921, is pretty close to 0. So that means the answer is also pretty close to this. I will take it to 2 to 3 significant figures. Any confusion about this question? Understood by interval bisection? No issues. Okay. The next thing is asking us about section 3, combinations and permutations. When I think, no, this is a combination question. No, this is a permutation question. Okay. Usually them ask both because most it's a hard question. Okay, it says there are 3 letters from the word bridge are selected one after the other without replacement. When a letter is selected, it is considered as either a vowel or a consonant. Use a tree diagram to show the possible outcomes, vowel or consonant, of the three selections. Show all possibilities, all probabilities on the diagram. So we start here. And the first thing is that we can pick a vowel, or we can pick a consonant. Let's continue creating the diagram from here. So from here, we can select another vowel, or we can get a consonant. And then once again, a vowel, a consonant, repeating the process, a vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. So now, remember that it tells us that we need to have all the probabilities. So on the first draw, there are a total of 1, 2 vowels. So that's 2 vowels out of 6 items. So 2 over 6. And then the consonants will be 4 consonants in a total of 6 things. Now, after one of the vowels is gone, we're going to only have 1 vowel out of 5 letters to pick from, while the consonants are going to have 4 out of the 5 to pick from. When we pick 2 vowels, we will have 0 out of the 4 to pick from. And then we'll have to pick a consonant pretty much, okay? In the case that we only picked in the case that we only picked 1 vowel, and then, so we travel on the sign a vowel and then a consonant, we're going to realize that we have 1 consonant remaining still, 1 vowel remaining. So we have 1 vowel gone, 1 consonant gone. We're going to have, for the vowel, we're going to have 1 vowel left out of 4 letters, and 3 out of 4 of those are consonants. Same process is repeating. We go this time, we're going to start from the beginning. And we're going to say, imagine we took out one of the, so we took out one of the consonants. We're going to have 2 vowels out of 5. And for the consonants, we have 3 out of 5. Then, imagine we took a vowel. So following this path, so we took a consonant and a vowel. We're going to have 1 vowel to choose from out of the 4. I'm going to have 3 consonants to choose from. If we instead had taken 2 consonants repeatedly, we would have 2 vowels to pick from out of the 4, and we'd have 2 consonants to pick from out of the 4. So this is the tree diagram. Any problems with this tree diagram? We're good with this, understood what happened.
I'm good with it mostly, but I just wanted to know why we just in drawing the branches we repeated the vowel and the consonant, but there was no reason for it to change. Like, is it because every time we draw, it's just we assume that we're drawing for the first time, that it's fresh, or
I don't think I fully understand the question, but I don't think I fully understand the question.
I barely understand what I'm trying to ask. But what I mean is, like, sometimes with tree diagrams, hold on. Sometimes with tree diagrams, like it changes up, like the vowel, like what we draw the branches would change. The values of the branches would change, not just the numbers, but like the items attached to it.
Yeah.
But I feel that we repeated vowel consonant for each branch. So I was wondering if there's something in the question that told us that we should Like something that indicated that we should?
The question specifically said that we're only looking at two possible outcomes, being vowel or consonant. So whenever we drag something, we don't look at, oh, is it a R or is it no? We just ask, is it a vowel or is it a consonant? Now, in the case later down, you're going to also see another question. It's going to have to change what is here. But in this case, it's just say, okay, we picked a vowel, we're going to pick again. Did we pick a vowel or did we pick a consonant? We just keep repeating the same outcomes, but the numbers change because we don't replace them again. Make sense?
Yeah, it makes a lot of sense. Thank you.
Okay, so the next question now, no, it's after that, oh, after that one as well. Okay, so B now asked about linear equation and augmented matrices. Okay. Matrices, this. It's asking, why is this thing not chugging where it needs to be chugged? Okay. So it says, okay, this is a matrix which is representing some linear equations, because remember, linear equations, matrices, all that linear algebra stuff are all connected together. It says determine whether or not the system of equations is consistent. Consistent just means, is this equation solvable? So to do that, we just have to solve it basically. Like to find out if it's consistent, we just have to solve it. I think that's easier to just explain that. So to solve it, it asks us to do it in echelon form, which means we should continuously use matrix operation. We should not be attempting to turn it into linear equations and solving it like that. We need to do the official equations. So what we're going to do is that we're going to do row operations. And we're going to say that, okay, row 2 will become, row 2, we're going to add 5 times row 1. Why we do that? Because we want to cancel out this term. So how do we cancel this first number? We're going to times this by 5 and add it. Make sense? Okay. So we add 5 to that, and we get as a final result here being 0, 6, look at it. Make sure I'm not gonna mess up this. -5 plus 1 gives us -4. 1 times 5 plus 2 gives us 7. Now we're going to do the same thing for row 3. For row 3, we want to eliminate this, right? Yeah, we want to eliminate this. So what we're going to do is we're going to subtract 5 times R1. Yeah, let's do that. So we're going to now have 1, going to have -5 plus 1. Nope, that's not how, it's not the correct thing. We want to remove this. That means we just want to subtract R1 from it. So this becomes 0. That 1 there now becomes 1 minus -5, which is 6. And that becomes 3 minus -1. Oops, let me make sure I'm not messed up. -5 minus 1. Doesn't matter the orientation. So this is going to become -5 minus 1, -6. It's going to become 3 minus -1, which is going to become 4. And then this is 3 minus 1, which is 2. Cool? So this is the same this is the same matrix 1, 1, negative 1, 1. Now, to test if it's consistent, we're going to realize that this row, we can cancel this row, right? So we're going to say that row 3 is going to become plus row 2. And then we're going to get 0 plus 0 is 0. 6 plus negative 6 is 0. Negative 4 plus 4 is 0. 7 plus 2 is 9. It is inconsistent. Why? Because we're saying that 0 times x plus 0 times y plus 0 times z is somehow equal to 9. This is what this row is saying, you know. Which makes no sense. So it's inconsistent. It has no solution. Cool? Any confusion with that question?
I hate to be the one that keeps asking questions, but for the first line you said, to cancel out the negative 5, we added 5. And then you went on to add 5 to all of the figures in the first row, I assume. But then when I look at it, it's you have 0, but I know 1 plus 5 is like 6. So I was confused with
Oh, okay. That's what you're saying. So let's take one step back and let's look at row 2 again. For row 2, what I'm saying is I'm going to add to row 2. I'm going to add 5 times row 1. So times row 1. Hold on. Multiply row 1 by 5 to give us 5, 5. So this becomes 5. This becomes 5. This becomes negative 5. This becomes 5. And we're going to add that to row 2. So 5 plus 0 0.5. 5 plus negative 5 is going to become 0. So this becomes 0. So we're not changing row 1 now. Row 1 isn't changed. We're changing row 2 based on row 1. So that's 5 minus 5 is 0. 5 plus 1 is 6. Negative 5 plus 1 is negative 4. Did that make sense?
yes,
So we're not changing row 1. We're changing row 2 based on row 1. So at the end of the day, row 1 remains the same.
okay.
And then we continue the process. So 2 plus 5 is 7. The same process we're doing for row 1. For row 3, we're going to say whatever it is, we're going to minus row 1 from it. Row 1 is 1 and 1. So we did all the things for row 2, which means that we're done with the math for row 2. So we can erase everything. Erase all of that part. And then we need to do the same thing for row 3. So row 3, we say we're just minusing row 1 from it. Minusing row 1 is going to be 1 minus 1 is 0. 1 minus 5 is 6. No, 1 minus minus 5 is 6. Negative 1 minus 3 is minus 4. 1 minus 3 is negative 2. Now realize that this 6 is a positive 6 here. This 6 is positive, this 6 is negative. This 4 is, it doesn't matter because it's the same thing as if I just multiply this entire thing by negative 1. So it doesn't matter the negatives in it, okay? So then the last thing is that we did an addition to row. Realize that row 1 and row 2 and row 3 look the same. We add them together and we get 0, 0, 0 and a 9 on this side, which we're saying this is inconsistent. It makes no sense because we can't add zeros together and get 9. Because this is just saying this is the equation 0x plus 0y plus 0z is equal to 9, which makes no sense. So it's inconsistent. Cool?
Yeah, thank you.
Okay. Now the next question says, okay, you did your math. Now they're saying we're going to replace the third row with this one. So this is a new third row. Determine if the solution is unique. So we're going to say the new matrix is going to look like this. It's going to have 1, 1, negative 1, 1, -5, 1, 1, 2, 1, -5, 5, 3. I changed row 3 to match what they said it is, okay? That's what happened. Now we need to do the same math and find out if the system is unique. That's all it's asked. It didn't ask us to solve it, and I said, is the system unique? Okay. So remember the step that we want to do is that we want to cancel. We want to cancel what is in these columns. So in this case, we're going to say, okay, row 2 is going to become row 2 plus, or we won't cancel it, plus 5 times row 1. In that case, we get 0, and then we'll get 1 plus 5 times 1 is 6, 4, 2 plus 5 times 1, 7. Okay. And now we need to do the same thing for row 3, where we're trying to get a 0 in this spot. To get a 0, we just need to say row 3 is now going to be row 3 minus row 1. In this case, we get 1 minus 1 give us 0. -5 minus 1 give us -6. 5 minus -1 give us 6. 3 minus 1 give us 2.
So that's why you were saying that it could be flipped around. The signs depends on whether you subtract row 3 from row 1
Yeah.
or row 1 from row 3.
Exactly. So it doesn't, the
Okay.
long as you keep, like if everything is negative, make sure you keep it in the same thing. So if earlier up here, I had a +6 here, it's important that when I do my math, this should have been negative, this should have been negative. But the actual sign in front of it doesn't matter because it's like multiplied by -1. It doesn't change anything. So for this now,
Okay.
we now need to get rid of, so we got rid of these 2 zeros. So this and this became 0. Our next step is to turn this into 0. How do we turn this last part into a 0? Way I'll do that is I'm going to say, okay, R3 is going to be defined as R3 plus R2. Why? Because if we add R2 and R3 together, we get 0. Yes, Jasmine?
Sir, where you have 4, is it supposed to be -4?
Right here?
Yes, sir.
Maybe. Let me check. So that's 1 plus 5 times -1. It should be -4. Yes. -4. Thank you. So row 3 is going to be the addition of row 2 and row 3 together. Why? Because if we add row 3 and row 2 together, we're going to realize that this is going to give us 0. So row 3 is going to become 0, 0, and then 6 plus -4 is 2. 7 plus 2 is 9. Now it asks us about a unique solution. Yes, it does. Why it has a unique solution? Because I have z is 2z is equal to 9. That's what that's what this says. That last row says that 2z is equal to 9, which if we have a value for z, then it's consistent, which means that there exists a unique solution. Okay? So since we have a value for z, and these are all linear equations, then they will intersect at one point, and it's unique. Make sense? Any issues with that?
No issue. So you're saying that once it's consistent, it has a unique solution.
Not,
Also,
not necessarily, because it could also be the case that you get something like 0, 0, 0, 0, which is consistent, but this is a trivial solution. That means, say, as in, you realize that this makes sense. Like adding zeros together, zx plus 0y plus 0, z equals 0. Like we're saying that, okay, this works. This is correct. But it doesn't have a unique solution because we don't know what z is in the case. But z has a value here. So if z has a value and it's consistent, then it's unique. Cool?
Yes.
Okay. The next question says, okay, next question is probability. Probability. Okay, so for this question, I'm going to do it the longer way because I want to show that sometimes the tree does in fact have different values. Because in this case, okay, so the country X has 3 airports, A, B, and C. The percentage of travelers that use each airport is 45, 30, and 25 respectively. So that means that if it's a tree, we have a point A, it can go to A, it can choose B, and it can choose C. If you choose, the probability that I choose A is 45. Probability that you choose B is 30. And probability that you choose C is 25. Now continue reading the question. Given that a traveler has a weapon in his possession, the probability of being caught is 0.7, 0.9, and 0.8 for airports A, B, and C respectively. Okay, so it's saying that if you're in A and you are caught, D, they said that D is the denotation for being caught. I don't know why they choose D, but okay. So if you're in A and caught, it's 0.7. That means if you're not caught, then this has to be 0.3 because remember it has to add up to 1. And then for B now, the probability that I get caught is 0.9. Then the probability I don't get caught from B would ultimately have to be 0.1 because remember it has to add up to 1. Same process for D. For C, it's 0.85. So 0.85 if I get caught. And so it's 0.15 if you don't get caught. So now you notice that sometimes it can have different values for the nodes. So it can be A, B, and C for the first part, and then D, not D, D, not D, D, not D. Okay? So sometimes it can be different. But in the earlier case where we had vowels and consonants, those are the only things that we had. We didn't have A happening and not getting caught and getting caught, just vowels and consonants. So for this now, it asks the actual question. What's the probability that a traveler using an airport in country D is caught with a weapon? Country X, as in, okay, so it's asking the probability of getting caught overall. We could use this, or we can learn the formula, which is the probability of D is the probability of D given A times the probability of A, plus the probability of D given B times the probability of B, plus the probability of D given C times the probability of C. What is this really saying? Well, this formula is also derived from the tree over here. What's the probability of D? It would be going along this line plus going along this line plus going along this line. So we have 3 paths that we can take. And this path is going to be probability of 0.7. It's going to be 0.7 times 45%. How we get this answer is the same thing happening here. What's the probability of D given A? That means we're already on the A path. What's the probability of D happening? So that this first section is 0.7 multiplied by what's the probability of A? 45%. So you see how this equation and this tree is saying the same thing, right? There's no confusion with that part. Good at that? Yes, okay, so the next part is to actually fill in these answers. So this is 0.7 multiplied by 0.45. Remember, you need to put it all in the same unit basically, so not percentage, but as decimals. Probability of D given B is 0.9 times the probability of B, which is 0.3, plus the probability of C of D given C is 0.85 multiplied by 0.25. The final answer is 0.7975. Cool. No, so that's part I. Let's do part 2. So as I say, on a particular day, a traveler was caught carrying a weapon at an airport in country X, okay? What's the problem is that the traveler used airport C. So it's saying that what's the probability that he got caught the probability that he was in airport C given that he was caught. Okay? This is not the same thing as a probability of being caught in C. It's not the same thing. So I have to read it as the probability. We're finding the probability that he was in C, the airport C, given that he was a caught man. Okay? And in this case, this is the probability of C and D over the probability of D. The probability of C and D is equal to 0.25 multiplied by 0.85. So it's asking you, you're on this path, C and D happened, divided by the probability of D, which we calculated earlier, to be 0.7975. Plug in a calculator, you get 0.25 times 0.85 over 0.7975. We get 0.266. Okay? Any issues with this question? Good, right? No issues with it. Okay. The next part says, the next part is modules 3. We're in module 3. Was the last question? Okay. The last question, and will always be, yeah?
No, I said no.
Okay. The last question is a differential question. The first one is a first order. So this is first order. In unit 1, you learned about linearly separable separation of variables, which is when you kind of integrate both sides by putting the y over there and the x over there. In this case, we can't do that because we're in unit 2 now, which means any question you have will likely not be that. So the first step is to rewrite it in a form, right? We want it in the form. We want it to look like this. We want it to say dy dx plus p of x y equal q of x. You want it to look like that, where p of x and q of x are just some functions. So how do we go about doing that? The step is we need to get dy by itself. So we're going to divide the entire thing. We're going to multiply the entire thing by 1 over cosine of cosine x. So that becomes dy dx plus sine over cosine is tan x y equal 2x cosine x. Okay? Okay? Now, we're going to say, okay, this looks exactly like the form that I need it to look in. So we have P of x is going to be tan x. Q of x is going to be equal to 2x cosine x. Now, we are going to say let u is equal to e to the integral of p of x dx. This is e to the integral of tan x, which, if you know the integral of tan x, which you should be very well acquainted with, I don't know why it wouldn't be, that is equal to e to the negative ln cosine of x. So just to be clear, the integral of tan x is equal to negative ln cosine of x. This is something you should know, okay? And then that becomes 1 over cosine of x. Why? Because the negative goes inside. Ln is going to become, so it's going to become e to the ln of 1 over cosine of x. This ln is just going to make us transform down to 1 over cosine of x. Cool. Now, after you do that, we're going to simply say our final solution, y is going to be equal to hold on. It's going to be equal to 1 over u multiplied by the integral of q x u dx. So this is the answer. You need to fill in the stuff, fill in everything. So that is now y equal 1 over u. So 1 over cosine of x is just cosine of x multiplied by the integral of 2x cosine of x, which is, in this case, this is q. And u is 1 over cosine of x. So this cosine cancel this. So that's cosine of x the integral of 2x is going to be x squared plus c. And then that final answer gives us y is equal to x squared cosine of x plus c cosine of x. Cool, no issues. Now, the next part, well, I'm just asked clearly. Any issues with the general solution that we found?
Oh,
No issue.
none with the solution. Can you just scroll up so I can see something?
Okay.
E to the negative ln of cos x is equal to e to the ln 1 over cos x. I understand that e to the ln would cancel itself out, but when you had cos x, why did you change it to 1 over cos x? Is that just like identity? Do we just know that cos x is the same as 1 over cos x, or
No,
is there
it's not
some
the
kind of
same.
thing that?
So I can write the steps in between here. So the correct steps is that this negative goes inside the bracket, right? And then we get e to the ln of cosine x negative 1. This negative one is not,
Oh,
this negative one is not the same as cosine negative 1 x. It's not the same. Okay, make that very clear. This one is arc cos or cosine inverse This is 1 upon cosine of x. Okay?
Yeah.
Okay, good. So then this now was rewritten as cosine of x all to the power of -1. Make it very clear that it's
Yeah.
not the same thing as inverse. Do not, if you write this, no matter what else you write at an idea, you get the question wrong. Okay? This is not the same thing. Okay. Very important. So
Okay.
yes,
But
that's example there.
okay. And we just had the liberty to like change the sign because you switch the negative ln and you put the negative sign to the like you just put it to the on the cosine. That's fine. In any case, we're allowed to do that. We can just switch it up like that.
Yeah, because remember
Okay.
it's that a log of anything is the same thing as log b of a, as in putting the a
Oh, I
inside.
didn't see that. Okay.
So
Thank
in this
you.
case, it's just -1. Yeah. Okay. So down here, this is the general equation. So this is just like memorizing. A lot of this is memorization up to this point. Unit 2 is a lot of memorization compared to Unit 1, where it's more deriving stuff. So this is the answer. And it says that, okay, great job, you found the answer. Now find the constant of integration given these values. So let's copy these values down to here and plug it in. Oops, this. Okay. So y is 15 square root 2 pi over 32. 15 square root something, square root 2 pi squared, square root 2 pi squared over 32 is equal to pi over 4. So replacing the x and the y, by the way, that's what we're doing. So this is part 2. All of this squared cosine of pi over 4 plus c cosine of pi over 4. Okay. Um, nah, just plug in a calculator. I was plugging in a calculator. So that's 15 square root 2 pi squared 32 minus pi squared over 4 squared 16 cosine pi over 4. So C is going to be 15 square root 2 pi squared over 32 minus pi squared over 16 cosine pi over 4 all divided by cosine of pi over 4. So that's 15 square root 2 pi squared 32 minus pi squared 16 cosine pi over 4 over cosine pi over 4. The answer they look ugly, but the expectation is kind of that. So this becomes 8.64 to 3 significant figures. Question, finish there, so finish there, so. The next question would likely ask about second, yep, it asks about second general solution. So okay, it breaks apart into different questions for you. Usually keep just like says, okay, here's it, solve everything on your own, but it breaks it apart, so that's good. So let's do the first part, which says, forget what this is, like this is not important now. It says calculate the roots of this. So let's do that, calculate the roots. Why is okay. So this is finding the roots of this equation. So we want something that adds up. Okay. So this tells that it's the same sign. This tells that the sign is positive. So it's positive, positive. Wait, hold on. Excuse me. This question is asking me. Oh, 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 oh. Okay. Yeah, so this is not, huh. Okay,
Would
it's
you use
fine.
like the negative b plus
The
or minus
roots,
root of like the
repeat.
equation? I said, would you use like the negative b plus or minus root of b squared minus 4 times
Yeah,
AC over 2? Is that what you just kind of would
hold on,
you
hold on. Hold on. You have to slow down with me. I think you have an accent and you have to slow down. So one more time.
I was saying, wouldn't you use the, I forgot what they call it, but negative b plus or minus root of b squared minus
Yeah, the
4?
quadratic formula. I was
Yes,
hoping
the quadratic
that
formula.
this didn't require it. I assumed that it was going to be factorable, but it's not. It's not factorable at all. Um,
Mhm.
okay. Um, okay. It's fine. We're going to, so I give it 2 marks if it's actually so much work. A equal 1, B equal 2, C equal 5. The quadratic formula is going to tell us that lambda is then going to be equal to negative b plus or minus the square root of b squared. You see, that's my problem because like, okay, b squared minus 4ac. Then why is it 2 marks over 2a? So then this is minus 2 plus or minus b squared is 4 minus 4, a is 1, this is 5. Oh, because it's a simple one. Okay, good. Okay, it's a simple. That's why it's okay. So that's equal to negative 2 plus or minus 4 minus 20, negative 16 over 2. So then this gives us negative 1 plus or minus 2i. Because the square root of this would be 4i. And then divide that by 2, we get 2i. Okay. So that's the roots. So lambda equal 1, negative 1 plus 2i or negative 1 minus 2i. Okay, that's why it's 2 marks. I assume that it's going to be a harder quadratic if it was, imaginary numbers. Okay, 1 second. Okay, so taking a step back now. Okay, so the complementary solution, complementary function. It's because it's imaginary. You see, the thing is, does everybody learn about this? Should probably assume they don't.
So there's a formula that's like a constant
Repeat.
formula. I'm gonna find the formula we need to plug in the solutions into. So give me a second.
Mhm.
Okay, so for complex roots, the formula is y equals e to the m1x. So m1 would be the real part of the solution and m2 would be the imaginary part of the solution. And
I'm
then
sorry.
that's
Can
times.
you talk a bit louder?
Oh, okay. And then that's times all by a cos m2x plus b sine m2x.
My question now is that, is this something that everybody on this call would know? Because again, this is at the end of module 3, so I don't know if like the teachers just like, yeah man, don't nobody do that question, because a lot of teachers will just say, get your marks in module 1 and module 2. So do I need to derive this and show? No. Memorization, okay. So for complex roots. Okay.
Why would this be the complementary function?
Why would this be it?
Yes.
I don't think I understand the question.
Okay, so I know when you trying to find the complementary function, you're supposed to do the identity of the equation in while you familiar with how the form in. Why would this be the form?
Okay, I'm going to try to I'm going to assume the question you're asking is, how do I know that this is the complementary function?
Yes.
So the complementary function comes from the roots that you had originally. So these roots, and then because it's complex, it's written in the form of e to the minus real part. No, e to the real part, x, doesn't matter which one I use, multiplied by a cosine of the not real part plus b sine the not real part.
Okay,
Is that
thank
some?
you. Yeah,
Mhm.
this is what I was asking.
So the thing is, there's multiple others. For example, if it was not real roots, you need to know different complementary function that it will have. And I recommend that you just memorize it, because there's no reason to ever be deriving any question like that. Okay. So now that's that. And then the next question asks about particular solution. It says, given the particular is of that form, show. Geez, okay. These are a lot of really small mark questions for things that usually require more work. Okay, so it's saying that the particular integral is of this form. Show that a will be negative 16 and b will be 4/17. Okay. So the step is to write u being equal to a cosine 2t plus b sine 2t And what we're going to do is that we're going to keep differentiating it. So we're going to have u prime, 1 prime, sorry, is equal to
This is the same
negative
question.
2a,
We found the complementary function.
repeat,
We found the complementary function, or did you skip the question?
the question above it?
Yeah, we found she gave the formula, but
Mhm.
that's all we need, just the formula.
If that's all we need for this part,
Yeah,
I'm pretty sure.
okay. Thank you.
I can double check.
Oh,
Complementary
it's okay,
function.
it's okay.
Okay. So because that is the reason I think the reason it's 3 marks is because I think they want you to derive it. But
Okay.
they don't know.
Sir,
Just no.
sir, don't you have
Um,
to plug in M1 and M2 into that
repeat.
equation? Don't you have to plug in M1 and M2 into that equation?
M1 and M2 being negative
The
1 and the 2.
oh, yes, sir. Okay.
Yeah. Okay, here. So you just start with the u that they told you, and then you're going to just keep differentiating it. So that's negative 2 sine. So differentiating with respect to t. So that's negative 2a sine 2t plus 2b cosine 2t. U double prime is equal to negative 4a cosine 2t plus 4b negative 4b negative 4b negative 4b sine 2t, which if you look on it, you realize that this is negative 4 open bracket a cosine 2t plus b sine t, which is just negative 4u, right? It's that I'm not missing something. I need to put that in. No, I don't need to do that. Okay, no, it doesn't matter. I don't need to show that. I didn't need to show this part. I'm going to have to use it regardless. That is true, but you don't have to show it. So then now we're going to have to plug in for the y prime plus 2y prime plus 5 plus 5. 5. Yes. 5y is equal to 4 sine 2t. Okay. Now the step they have to do is they have to put all of these in to this new equation. So all these are worked out. You want to put them in here. So that's now going to become negative 4 a cosine 2t. No, I don't need to show you that. No, we're going to do a selective expansion again. Show them that we don't need to do that. So we're going to say for the cosine, for the cosine 2t term, the cosine 2t terms is going to be 5 times this a, so that's 5a 2 times this 2b. Remember, it's going to be right here, so that's 2 times this 2b. And in the y prime, which for the cosine is going to be negative 4a. We're going to assume that those are correct unless otherwise stated later. And on the right-hand side, which is this side, there is nothing. For the sine 2t term, we're going to have different color. We're going to have this b in this position, so that's going to be 5b. And then the sine 2t here is going to be negative 2a, but it's going to be in this position, so there's going to be a 2 in front of it. And then in this position, we're going to have the negative 4b, minus 4b. We're going to assume that this adds up to what I need to add up to. Let's find out. No, this is not 0. This is 4. Yep, okay, so let's which method do we use? Elimination? Sure, why not? Okay, so this one simplifies to A plus 4b equals 0. This one simplifies to so lots of moving parts. That's a b. There's a b there, and there's a minus 2a minus 4a equal 4. It might not look right. Okay, next step, solve these two equations. You're at cape level, so I believe you can say by solving a plus 2b equals 0 and b minus 4a equal 4 simultaneously. A was found to be, plug in a calculator, minus 16 over 17. B equal 4 over 17. Is that what they told us to find first? Yes, okay. And the solution. The reason I didn't work out the solution simultaneously is because I don't need to. As in, you're at the cape level, they assume you know to do that part. Everything else, though, you have to show it. So the last question says, I have space here. Let's start somewhere else. I don't know, go ahead. Yeah, you can start here. Paste. So earlier, we found the general solution, right? Now they're saying that, okay, love that for you. We found a complementary solution earlier, right? But now it's time that we have to find the rest of the things. The general solution is going to be the total earlier. We told us earlier that. Told us earlier the general solution is the complementary function plus a particular integral. So that's equal to the complementary function plus the particular integral. So that becomes e to the negative t, open bracket, a cosine of 2t plus b sine of 2t. This is from the complementary solution, plus the particular integral, which is negative 16 over 17 cosine 2t, plus 4 over 17 sine 2t. So this is what y is. This is y of t, by the way. You could have had y of x from the very beginning or anything I feel like, but you know, it doesn't matter. Okay, so at x equals 0, we have 0.04 is supposed to be equal to e to the negative 0 a times cosine of whatever this is going to be 0 plus b, whatever this is, sine of is going to be 0 plus minus 16 over 17 cosine 0 plus 4 over 17 sine 0. So let's throw away anything that will be, so this is going to be 1. This is going to be 0. This is going to be 0. This is going to be 1. This is going to be 1. So now we have 0.04 is equal to a minus 16 over 17. So that means a is going to be equal to 0.04 plus 16 over 17. So that's 0.04 plus 16 over 17. That's a pretty bad number. Oh. It was decimal. 0.9812. 3 significant figures. Okay. Any confusion with that part? No, we're good. Okay. So the next part now is we want to find b. To find b, we'd go have to differentiate y. So that's y prime is going to be equal to it's going to be equal to e to the negative t. So it's a product rule. So it's e to the negative t multiplied by the differential of what's inside. It's going to be 2a negative sine 2t plus 2b cosine 2t. And I need to add to that the differential of the outside, e to negative t, remains the same. Nope. Minus t in front of it now. Multiplied by a cosine 2t plus b sine 2t. So that's us differentiating this section. Now we have to differentiate this section. So that becomes, add to it, negative 16 over 17 cosine makes it negative 2 sine 2t plus 4 over 17 times 2 cosine 2t. We're going to plug in 0, because that's what it says. We're going to plug in the same 0. When we plug in 0, let's find out who is going to be 0 now. So plugging in 0, we get 0 here. We get 1 here. We get 1 here. We get 1 here. This sign becomes 0. This cosine becomes 1. This sign becomes 0. This cosine becomes 1. Okay. So at the end of the day, we are left with y prime at x equals 0 is going to be negative 2a. Nope. Go back. Is going to be equal to 2b this part that is, minus A what else left? Plus 4/17 times 2. And that should be equal to what they told us it's equal to, which is, it says equal to 0. Okay, 0. So that means 2b is equal to minus 8/17 plus A. A in this case we found to be 0.981. So that's negative 8/17 plus 0.981. This is equal to 0.510. And then B is divided by 2. We get B is roughly 0.255 to 3 significant figures. Any confusion on that question? We're going to do it right. No issues? Okay. Then the final step is to rewrite this. You write the general solution, plugging in B and A to be the correct values that you found them to be. Now, that's the last thing. And then I saw somebody sent a question that said, Gmail, what's up? Oh, wow, okay. So I got a question. Okay, so that's, we're about to finish up. We're going to the last question from what somebody sent, which was, I don't know what paper it's from, but somebody sent a question, so I'm going to do it. What is this? Question. Okay. That one I wrote. Okay. The last question is something that somebody sent me, which is, given that 1 minus I is a root of this equation, find the remaining roots. Well, the first one is that if one root looks like this, if one root of the equation looks like this, then the other root has to look like this. So that means there's two roots. We know at least two roots. So that means we'll have z equal 1 minus I and 1 plus I as roots. And there's a third root, which is likely real. So the way that I do this is that I would say, recall alpha, beta, gamma must be equal to d over a, negative d over a. So that means we'll have 1 minus I, 1 plus I, multiplied by what we don't know what z is yet, is equal to negative 6 over 1. negative 6 over 1. So let's expand out this. So this is the, we're going to, before I even expand it like normally, I'm going to make you guys aware that this is difference of two squares, which means that this is 1 minus I squared as the answer, which is 1 minus negative 1, which this is 2. I'll just carry down the z's, and that's equal to negative 6, which implies that z is equal to negative 6 over 2, which is negative 3. So that means we found all the roots. So the all roots are going to be 1 minus I, 1 plus I, and the real root negative 3. Cool. So let's recall, if we have one root, which is a imaginary number, the other root must be the conjugate, and that means we'll have two roots. Recall that the product of these roots must be equal to negative d over a. That's from unit 1 pure math. So this is unit 1. Then we see we're multiplying the roots together. So we have the root 1 minus I, 1 plus I, and we have z. 1 minus I times 1 plus I is 2 times z is equal to negative 6. Z must be negative 3, which means that our roots are the one they gave us, the conjugate, and the one we found, negative 3. Okay? Any questions about that question? Good at that, right? No issues. Okay. That's the end. Have a good night. Bye-bye.